So today for my lesson, I'm choosing to talk about the chain rule in multivariable calculus. So what I would start off with is basically talking to the students about the two different types of chain rules, which in this case are going to be your multivariable chain rule and then single variable chain rule, and I would show the difference between each of them. For multivariable chain rule, you basically multivariable. Okay. If you're trying to find the derivative of z according to t, you have to find each individual one. So you have to do the derivative or the partial derivative of z over dx multiplied by just the normal derivative of x according to t, and then adding the same thing but now for y. So the derivative of z over the y partial derivative times the derivative of y over dt. That's multivariable, whereas single variable is where you convert your x's and y's into forms of t and then take the derivative according to there. So I would talk to my students about, in this case, this is from chapter 13.5, so if they ever had issues, they could look back at that. So what they should be able to do by the end of the lesson is be able to compute partial derivatives with various versions of the chain rule and then be able to compare your answer with the direct method. So I would show them both ways, okay? So I think the best way to do this would be in terms of an example. So I would be starting off with just like what are the two different ways. So starting off with, it says find dz dt by using the chain rule. Check your answer by expressing z as a function of t and then differentiating. Okay, so I would start off with is I would actually start off with showing them the multivariable calculus way. So when we're doing that, you have to follow this exact formula exactly. So looking at z first, okay, what I would do is I would start off with finding dz over dt, okay. And so from there, what I would have to do is start with finding the derivative of z according to x. So in this case, I would emphasize y as a constant. So what I would do is the derivative of z according to x would actually just be 2 in that case because it's 2x, and then y goes away because it's just a constant. From there, I would have to multiply by dx over dt. So now looking at x equals sine of t, I'm just taking the derivative of sine of t, which in this case would be cosine of t. Okay, then I have to add the derivative according to y over dt. So starting off with now dz, but according to y, that 2x would go away essentially, and you would just be left with a negative one because that's the derivative of negative y. And then from there, multiplied by the derivative of y according to t. So in other words, that would be just times 3. Simplifying that, you would get the derivative of the partial derivative of z according to t would be 2 cosine of t. And then negative 1 times 3 would be a negative 3. So then from there, it says check your answer by expressing z as a function of t. And then differentiating. So what I would do is wherever it says x, I would replace sine of t, and wherever it says y, I would replace 3t. So in other words, this is our second method. It would be z equals, it's 2 times x, which is sine of t, and then plug in 3t for negative y, you would get negative 3t. And then I'm taking the derivative according to that, so dz over dt would just be, take the derivative of this, you would get 2 cosine of t, because that's the derivative of sine, and then the derivative of 3t would be minus 3, noticing how I get the same answer on top and bottom. So I would do a couple more problems like that, just maybe harder level problems with ease and natural logs, but that's kind of the idea of showing the two different methods, okay? So then from there, I would just talk about like different ways that you could see this rewritten. So it says suppose w is equal to x squared plus y squared plus 2z squared, where z equals t plus 1, y equals cosine of t, and z equals sine of t. find dw dt, use the chain rule, check your answer by expressing. So now I have 3 variables, which means that I have to actually do the chain rule 3 separate times. So just expanding that idea, I'm going to actually go down here for that. Okay, so what I'm going to do first is I'm going to just write out when I'm doing multivariable, you would do, it's dw over dt, okay? I'm going to follow the same formula, but now adding in z's as part of it. So you would do the partial derivative of w over the partial derivative of x times dx over dt, okay, plus dw over dy times dy over dt. And then plus, because we now have a z variable, which is sine of t in this case, it's going to be dw over dz times dz over dt. So just adding in that extra part. So I'm just going to basically fill that in. So looking at w, starting off with that, okay? When I'm doing dw over dx, everything goes away except x, so that would actually just be 2x times dx over dt. You're now looking at that, so it would just be times 1. And then plus dw over dy, that would be 2y, times the derivative of now t according to, or y according to t, would be actually negative sine of t, because it's cosine. And then plus finally, it would be 2z squared, which means it would be 4z. And then from there, times the derivative of sine would be cosine of t. So then just simplifying that, okay, you get dw over dt, which equals, it's going to be 2x minus 2y sine of t plus 4z cosine of t. But remember, we want everything in terms of t's, so we can just replace whatever we see with x with that t plus 1 and y and z. So your final answer would be this. So it'd just be 2 times x was sine of, or x was t plus 1, so it'd be plus t plus 1, minus 2, y was cosine, so it'd be cosine of t, sine of t. And then finally, for z, it would be plus 4. It would be, z would be sine of t, cosine of t. And actually, we could even take this one step further. You can combine these because they're the same thing. So your final answer would be, and if you want to multiply that through as well, your final answer would be 2t plus 2, and then adding negative 2 plus 4, that would be plus 2 sine of t, cosine of t. And that would be your final answer. And of course, we could check it with that other method that we just showed. Okay. So then furthermore, okay, if we were looking at like proving something, so I would say, okay, these two are similar to the problem that we just did, but if we're looking at proving something, so it says suppose g is equal to f of u minus v, v minus w, and w minus u. Show that dg over du plus dg over dv and dg over dw is equal to 0. So basically from there, okay, what we would be doing, okay, is looking at it in terms of this way. So in other words, if we were trying to find dg over du, okay, you're taking the derivative according to f, or according to u, okay? So in other words, this in here, just think of it as constants. So it would actually just be f of u, and then negative 1, and I would just keep going on for that until I got all 3 parts and equals 0. So overall, it's kind of a lesson where you have 2 steps, and we can just basically look at it in 2 separate ways where we would actually get the same results. But